Okay,
Hello.
Jason. Hello.
Hello. Can everyone hear me?
Yep.
Okay. Yeah, it's good to be with everyone. Yeah, today I'm going to talk about a comparison of mainstream marijuana and tobacco smoke. And to give credit where credit is due is, and to give you a little background, at the AAAR meeting in 2018, Brian, Tyler, and Robert came up to me and said, "We've got a great idea. Canada's about to legalize recreational marijuana. Why don't we do a study?" So they decided to spend their Christmas vacation all traveling back to Canada and coming to the U of A to measure marijuana and tobacco smoke to see how it might differ. So this was just recently published in Scientific Reports if you want to learn more about it later. Okay, so everyone knows that tobacco smoke is a major health risk, and I love to show this plot from the Lancet, which shows different risk factors and how many people die per year for different risk factors. And the first bar you see on the left is the is total pollution, and air pollution kills roughly about 7 or 8 million people per year. So that's what most of the talks were about today. We're on this column on the left. What I want to talk about is what's going on in the next column, which is tobacco smoking, and comparing that to marijuana smoking, which kills about 7 million people per year. So so what we wanted to do with the study is at least understand a little bit about how the health risks of marijuana smoke compared to tobacco, because a lot of people in Canada and perhaps in the world think there's essentially no or very little health effects or negative health effects related to marijuana smoke. So to put things in perspective, there's about 1.1 billion tobacco smokers in the world, but even though marijuana is illegal in many countries, there's still about 20 or 200 million people per year that regularly use marijuana. And Canada is one of the first countries to legalize it for recreational use. So there's no limitations, just an age limit on it. You can buy it without any special requirements, and presumably more countries will follow. And although marijuana can be consumed in many different ways, most of it is done by smoking. So in Canada, about 97% of the recreational marijuana is consumed by smoking it. Okay, so we wanted to understand what are the physical and chemical properties of marijuana smoke, and then we wanted then to compare it to tobacco smoke. Oh, okay, here we go. So so what we did is, for those of you who aren't familiar with these sorts of studies, you have to smoke either the cigarette, the tobacco cigarette, or the marijuana joint using a smoking machine or a smoking cycle simulator, and you need to follow a certain profile. So Health Canada, for example, has a specific routine for how these things could be smoked so that they can be sort of smoked in a representative manner. So Combustion was very generous, and they lent us their smoking cycle simulator, and we used that using the Health Canada Intense routine. And so what you do is you put the cigarette or the joint in the puff head, and what the machine does is it controls the flow rates and some sort of a breath, so some extra dilution air. It mixes those together and puts them into what we call a lung bag. And then what we do is we push that out into a sample bag, which we can then, with some dilution air, which we can then use, slow instruments to measure what's in the bag. And of course, there's particle losses and coagulation and things like that in the sample bag. I'm not going to talk about those issues today, but you can read about those in the paper. So the other thing we do is when it comes to tobacco, there's reference cigarettes. So there's the University of Kentucky sort of manufactures these cigarettes that are standardized and that everyone who does tobacco research around the world can use. And so we use the 3R, 4F version of this cigarette. And there's no standardization when it comes to marijuana, but we just bought some marijuana. In fact, Robert bought it at a dispensary in British Columbia. And I had an interesting conversation with my department head about how to reimburse him for that. But it all worked out in the end. He got his money back. The other goal of our project was to use as much combustion equipment as possible, because they're the sponsor of this conference. And so what we did is we took the sample bag and then we did all sorts of analysis with it. I'm not going to go into the details because you'll see how it all works out in the results, but a lot of the results are measuring the aerodynamic size using the combustion's aerodynamic aerosol classifier, the mobility size, the mass of the particles using a CPMA, and then also using a catalytic stripper from Catalytic Instruments to essentially test the volatility of these particles. The other thing we did is, so those were all from the sample bag. We also measured the total mass concentration by just putting a filter right behind the cigarette, so collecting it directly without any dilution or aging or anything like that. And then we did some chemical analysis, which I'll show you as well, directly from the filter. Okay, so this is the results in terms of size distribution. We've done it in terms of aerodynamic diameter and mobility diameter. And it makes more sense here to measure aerodynamic diameter because that will determine where the particles deposit in the lungs. And so the peaks on the right here, the red one is the tobacco smoke. The blue is the marijuana smoke. And you can see in terms of aerodynamic diameter and mobility diameter, you can see that the marijuana smoke is a little bit bigger. It's about 30% larger in terms of mobility. And then if you denude it or you pass the smoke through a denuder or strip the particles, what you can see is that the particles shrink and the concentration lowers a little bit. And that's because there's a lot of volatile material or semi-volatile material on the particles. Okay, but again, the marijuana smoke tends to be a little bit bigger than the tobacco smoke. And it's also the distributions are a little bit broader with marijuana. So the other thing that we can determine is the effective density of these particles. And what you can see here is all the data points down here are for the tobacco and the marijuana smoke. And you can see that the densities are all very similar to each other. So regardless of size, the effective density is about 1,000 kilograms per meter cubed. And the tobacco and the marijuana smoke is about the same. Just for reference, these gray shaded regions show the effective densities that have been measured in other studies for tobacco smoke. And it's all so very similar to what has been shown before. We also measured the effective density of the denuded or the stripped particles. And then you can see that the effective density is quite a bit higher, which sort of makes sense because a lot of the semi-volatile material would be organics, which have densities on the order of about 1,000, where if you remove that material, end up with residuals, perhaps elemental carbon, that's going to have a higher density. We also measured mass concentration, and we did that two ways. Because we measured the size distribution and the effective density, you can use that to calculate the mass concentration. So if you do it that way, you see that marijuana smoke has about 2.5 times higher mass concentration than tobacco. And that's because it was about 30% larger in size, even though that number concentration was a little bit lower. In terms of marijuana, and then the other way you can do it is just put a filter without any dilution or aging directly behind the cigarette or the joint, and then we get about 3.4 times higher mass concentration. Now, one of the big differences here is the tobacco cigarettes that we were measuring were filtered, while the marijuana joints were not filtered. And we did that intentionally because essentially 99.7% of cigarettes that are smoked around the world are filtered, while the vast majority, 95 or 96% of marijuana joints that are smoked around the world are not filtered. So we wanted to compare what's actually smoked rather than compare filtration. Okay, the other thing you can do with this data is look at how essentially the semi-volatile fractions of this material. So we split that out in a number of different ways. So we can look at the semi-volatile number fraction. And what we mean by this number is when you denude or strip the particles, it's how many particles that are left that have a non-volatile core to them. And what this number means here is that essentially most of the particles, when you denude them, have some sort of non-volatile residual. So maybe just a little bit, but there is some non-volatile residual there. The volume and mass fractions, which are of course very similar because these particles are spherical, are very, very high. So 98% of the particles, or high 90% of these particles, is essentially mostly semi-volatile material. So what we learned from this is most of the particles have at least a little bit of a non-volatile residual, but the particles themselves are almost all made up of semi-volatile material. Okay, the other thing that we did is we wanted to understand at least a little bit about the health effects. We wanted to see, measure, at least get some idea of the chemical composition of these things. So what we did is two-dimensional gas chromatography. So this is GC time of flight mass spectrometry. So one of these axes here is the retention time in one column. The other axis is the retention time in the other column. And then the colors represent the signal from the mass spectrometer. And so if you see a color that's more red, that means you've got a higher concentration of a particular compound. So when you see all these little dots here, what they are individual compounds that can be resolved by comparing them against a library. And so you can see, of course, that in tobacco, there's hundreds of different compounds, and there's some that you, of course, would immediately recognize, things like nicotine. So if I flip to marijuana, you can see that, again, there's hundreds of different compounds in the marijuana smoke, and there are, of course, things that you recognize like THC and CBD, which would be, of course, what you would expect in a marijuana joint. So if you sort of just flip between the two, you'll see that there's several differences between the smoke, but there's also many compounds that are the same in the tobacco smoke and the marijuana smoke. So I'm not going to go through all the detail of the chemical analysis, but what you can do is you can do, a relative quantification. So we can't do absolute quantification because we don't know the response of the detectors, but I'm just showing a few compounds here comparing tobacco and marijuana smoke. So of course, if you look on the far right-hand side, there's nicotine. So of course, there's lots of nicotine in tobacco and there's none in marijuana, but in other compounds, there's lots of that particular compound in marijuana relative to tobacco. So if it's hard to, because we can't, put an absolute quantification on these compounds, it's hard to determine exact health effects. But what you can do is you can see and look at which of these compounds, when being compared against a library, are different or the same between the tobacco smoke and the marijuana smoke. So if you look at known carcinogens, you can see in terms of group 1, 2A, 2B, and 3 that there's, dozens of different carcinogens. And if you look to see how many are common or between them, many of them are common between the two. And then with mutagens, of course, there's, again, dozens of different mutagens, and some of them are common between the two. Okay, and there's other toxic chemicals. So what we know is that there's, there is a lot of chemical differences between the two, but there also are a lot of compounds that are shared between the two. Now, there's lots of caveats with this sort of analysis. So essentially, we're only detecting things with carbon from sort of C6 to C25. And this isn't an absolute quantification. It was all done on a relative basis. Okay, so to conclude, there's lots of similarities and some differences between the two. So in both cases, most of the particles are semi-volatile, but they have a small non-volatile residual. The effective density for both of them is about 1,000 kilograms per meter cubed. There's dozens of carcinogenic and mutagenic compounds in both substances, and many of them are in common. The differences are, marijuana smoke, it's about 30% larger in terms of particles, and you get about 3 times higher mass concentration. Now, there's lots of different caveats with this study. So, essentially what we're doing is comparing the two. We can't exactly make exact statements about the health effects of the marijuana smoke. And we quantified the physical differences, but that will also depend on the sampling method used. So if we change the smoking cycle, or compared filtered cigarettes to filtered marijuana joints, and our sampling and dilution conditions will be different between the two, but of course they were held the same in this study, and so we're making a relative comparison. We only quantified the relative difference in chemical composition, and so if you wanted to really understand the health effects, we would have to understand about the dose and how that would affect things, and do an absolute quantification. And of course, the other, probably one of the biggest factors, is how much people smoke, right? So in Canada, a typical smoker smokes about 400 cigarettes per month, while a typical cannabis user smokes about 6 joints per month. So there's orders of magnitude different on how much smoke is consumed by the typical user of each. Okay, so we'd just like to thank Combustion, especially Chris Nicholas, who helped a lot and lent us the machine and provided a lot of assistance on how to use it. Fiona at Cambridge, who helped out, and these funding agencies. So thank you for your attention.
Thanks, Jason. We have got time for one quick question, if there's anyone who wants to ask one. Otherwise, we can always ask them in the chat if that's okay. I don't see anything, so
lots of interesting quips in the chat.
There are lots of interest. Yeah, this does seem to bring out the school children is all really. But oh, Joel's got his hand up. Joel, would you like to ask something? I'll unmute you.
Yeah.
Yep.
I was going to ask this question in the chat, but it might get lost in all the hilarity. How, as well, can we just directly say, can we directly roughly estimate from that orders of magnitude less that cannabis users own, what would the health effects be relatively from the tobacco literature? We should know something.
I couldn't quite hear that. I don't know, Johnny, did you hear that? Can you repeat?
No, I didn't hear any better than you did, I'm afraid.
I'll type. Okay.
Okay, should we do that via the chat then? Okay, in which case we'll move on if that's all right. Okay, thank you. Okay, well, next up we've got Steve Rojak from UBC. And Steve is going to be talking about the external mixing hypothesis for soot structure, supporting evidence and where it leads. So I imagine this has implications for climate change at a guess.